La relación entre los insectos y el ser humano ha sido, a un tiempo, de convivencia y de lucha. Pueden alimentarnos o destruir nuestras cosechas. Al parecer, esta batalla la van ganando los insectos, ya que han provocado las mayores epidemias en la historia de la humanidad. Le corresponderá a la ciencia encontrar en los próximos tiempos la cura para controlar y detener las terribles epidemias y enfermedades transmitidas por insectos. La relación entre los insectos y el ser humano ha sido, a un tiempo, de convivencia y de lucha. Pueden alimentarnos o destruir nuestras cosechas. Al parecer, esta batalla la van ganando los insectos, ya que han provocado las mayores epidemias en la historia de la humanidad. Le corresponderá a la ciencia encontrar en los próximos tiempos la cura para controlar y detener las terribles epidemias y enfermedades transmitidas por insectos. La relación entre los insectos y el ser humano ha sido, a un tiempo, de convivencia y de lucha. Pueden alimentarnos o destruir nuestras cosechas. Al parecer, esta batalla la van ganando los...
Bienvenidos al ciclo de conferencias Universidades por la Ciencia, organizado conjuntamente por Fundación UNAM y el Consorcio de Universidades por la Ciencia, que agrupa instituciones en México y fuera, en Estados Unidos, en Reino Unido, en Brasil, España, Argentina y Chile. Les agradecemos mucho su interés y que nos acompañen. Y hoy tenemos una conferencia muy especial a cargo de la doctora Marian Scott, de la Universidad de Glasgow, de la Escuela de Matemáticas y Estadística. Y el tema es particularmente interesante, es una visión digital de la Tierra, post-COP, ¿a dónde vamos? Está relacionado con la parte de cambio climático y también, si recordamos, pues la reciente conferencia internacional en Glasgow. Welcome to the Universities for Science seminar cycle, organized by the UNAM Foundation and the Consortium of the Universities and Research Centers in Mexico and in the US, UK, Spain, Brazil, Chile, Argentina. We thank you for joining us, and today we have a very special conference by Professor Marian Scott. She's in the School of Mathematics and Statistics in the University of Glasgow in Scotland, in the UK. The conference is a digital vision of the Earth post-COP. Where do we go? We thank Marian for this interesting conference, and it's great to have this collaboration with the University of Glasgow. We welcome Professor Annelena Gonzalez, who is the director of the UNAM-UK Center in London, and Professor Penelope Morris from the University of Glasgow. I'm very glad to see you again, Penelope, and we have the president of the UNAM Foundation, Dionisio Meade. Thanks all of you, and we are extremely happy to have Professor Scott with us today. Y le paso la palabra a nuestro presidente de Fundación UNAM, Dionisio Meade.
Muchas gracias, Jaime, por tus palabras y gracias a quienes nos acompañan otra vez en esta presentación que nos hace presente a la Universidad de Glasgow y que además pues, fortalece la convicción de que esta formidable idea de establecer un consorcio de universidades por la ciencia pues fue una medida en la dirección correcta. La pandemia nos había cerrado las puertas de la comunicación y entonces se diseñó esta idea de la mano de Jaime Urrutia con la participación del Colegio Nacional, con la participación de la Universidad de las Américas Puebla, con la participación de nuestra propia universidad y a la que nosotros nos sumamos pues con mucho entusiasmo porque nos dábamos cuenta de que estábamos dándole la vuelta a las restricciones de la pandemia y que estábamos estableciendo, y creo que así se ha venido acreditando en el tiempo que ha estado vigente este consorcio, que esta era una vía en donde podíamos compartir conocimiento, en donde podíamos aprovechar la sabiduría de nuestros expositores, en donde podíamos además sumar esta posibilidad de intercambio respecto de las investigaciones que cada uno de ellos estaban haciendo, y sobre todo porque nos daba la posibilidad de abrir a los jóvenes esta ventana de oportunidad para que eligieran dentro de sus opciones profesionales las que derivan justamente de las presentaciones que aquí se han hecho. Hoy nos da mucho gusto la presentación de la doctora Marian Scott, y es interesante, ella está en la Escuela de Matemáticas y Estadística, y el tema que habrá de ocupar es un tema vinculado con la sustentabilidad. Quiere decir que hoy la transversalidad del conocimiento y la transversalidad de las especialidades que se requieren para avanzar en la investigación y en el desarrollo de algunos temas reclaman pues visiones interdisciplinarias y reclaman también la participación en donde ya las fronteras pues tienen cada vez menos relevancia, y si en algún espacio no tiene ninguna relevancia, pues es justamente en el entorno de la contaminación ambiental. Nosotros hemos inscrito nuestras pláticas en lo que hemos llamado la nueva realidad, y es que consideramos que la pandemia nos dejó muchas lecciones, pero después de estas lecciones el mundo no va a ser igual, y una de esas lecciones es precisamente que tenemos que cuidar a nuestro planeta. Y es bien interesante este esfuerzo que se ha generado a través de la COP, de la que hoy habremos de escuchar comentarios, y que es un tema que hubiera sido inimaginable hace algunos años todavía, y que hoy ya forma parte de una agenda internacional, porque el mundo se preocupa cada vez más de cuidar nuestro planeta. Agradecemos mucho la presentación que se nos hace, agradecemos la presencia de la doctora Marian Scott y agradecemos a Penélope y a Ana Elena González que nuevamente nos acompañen el día de hoy, y justamente queremos subrayar que el tema que hoy se nos presenta pues es un tema muy relevante que está teniendo un impacto en todos los aspectos también de la convivencia, porque la gente, sobre todo los más jóvenes, van teniendo una mucha mayor conciencia de la necesidad de cuidar el planeta. Incluso es interesante apreciar que en muchos de los grandes proyectos, las entidades financieras están considerando este efecto de gravedad cero, de contaminación cero, como uno de los elementos para otorgar sus créditos. Quiere decir que ya también ha permeado en estas entidades la urgencia y la necesidad de proteger el ambiente. Esperamos que muchos jóvenes se sumen a estas presentaciones que ya son transoceánicas, y que pues justamente creo que la mejor respuesta sería que al final pues varios de ellos se acerquen a nuestros ponentes, como en este caso a la doctora Scott, para preguntar más sobre este tema, para expresar sus inquietudes sobre este conocimiento y para que vayan optando en su trayectoria profesional cada vez más por las ciencias duras, cada vez más, como en este caso, por la protección del ambiente. Muchas gracias a todos, agradecemos su presencia y les damos también la palabra si quisiera hacer algún comentario la doctora Ana Elena González y a la doctora Penélope Morris, antes de escuchar a nuestra ponente del día de hoy, a la profesora Marian Scott. Muchas gracias a todos.
Muchas gracias. Penny, perhaps you would like to speak before I introduce Professor Marian?
Just thank you, Anna and Elena. I just want to say very few words, just to say that we're delighted to be able to participate in this wonderful series of lectures. I think this is such a wonderful way of bringing the world together at a time when really we're having to be staying in our own countries more than we would like. And it's a fantastic way also of developing the collaboration between the two universities, which we're developing in lots of different ways. We're very keen to have staff and colleagues and researchers, students moving backwards and forwards, visiting each other when we have the moment to do it. And this is a wonderful way of collaborating in the meantime. So thanks again.
Thank you. Thank you very much. Well, it is my great pleasure to introduce Professor Marian Scott. You already heard a little bit about her. I'm going to give a very, very brief description of what she does. There's a little fly nearby, sorry. She is Professor of Environmental Statistics in the School of Mathematics and Statistics at the University of Glasgow. Her research interests span the environmental sciences, and in particular, statistically sound evidence, driving evidence-based policy, regulation and risk management of radioactive contamination, freshwater quality, air pollution, and health. She was awarded the Barnett Award in 2019 by the Royal Statistical Society for her outstanding pioneering research into the development and application of innovative statistical techniques to environmental issues. She has published widely in leading statistical as well as key application journals, including on the statistical principles design of experiments for metrology, psychometric approaches for validation of measurements of pain, spatial temporal models using flexible regression, and functional data analysis for environmental monitoring and modeling. That is quite amazing. And today we have a delightful topic, a digital Earth vision, post-COPs. Where do we go? Over to you, Professor Scott.
Thank you very much. I'll now try and make the technology work, I hope. Oh, no, hold on, I'll do that one. So hopefully everyone can see my slides, which is good. And just to say, it's a great pleasure to be here this evening in Glasgow, the morning in Mexico, and I guess similarly, different times of the day in different parts of South America. I've changed the title a little bit because I wanted to, if you like, slightly broaden our discussion this evening into thinking a little bit about how statistical science, data analytics is contributing to how we manage the planet that we live on. And hold on. So hold on a minute. I'm going to have to go back out and change this again because my slides are not moving. So let's hope that this will now work. Always interesting technology. Come on, you can do it. Right, and then I shall take off my presenter view, and hopefully now it moves on. Excellent, excellent. It's always good to know that something doesn't quite work, and hopefully that's the least and the most that we'll encounter this evening. So many of the examples that I'm going to talk about are a result of a variety of different collaborations with colleagues in Glasgow and wider beyond, and obviously PhD students as well. And clearly our funding for many of the pieces of work that I'm going to present have come from a variety of sources, but mainly the main UK research councils, including NERC, which is the Natural Environment, and EPSRC, which is Engineering and Physical Sciences. I'm going to cover a few things this evening, so it's a little bit of a whistle-stop tour, but the starting premise in some senses is that we have really changed how we measure and monitor the environment. And this has, I think, opened up many opportunities for statisticians and data scientists and data analysts to contribute to public debate and political debate about achieving net zero with respect to carbon, or indeed managing our, if you like, natural resources, whether it be biodiversity or water. In our discipline of statistics, there's been a lot of debate around some of these new areas like data science and artificial intelligence, and just how they connect into what we're actually trying to do, and the power that they can bring to understanding better what is actually happening in our environment, and how any interventions that we might make can change the course of our future. So for me, one of the big challenges that we have is that people are talking about data lakes, where we have new and more data streams being generated much faster than previously, and much, much more in volume than we previously had to work with. People have talked sometimes about whether or not this, in fact, is a data deluge, suggesting that we have a flood. And a flood sometimes is not exactly what you would wish to have. Are we taking full benefit of all of these different data streams? And the digital earth is really a vision of a fully quantified environment with supporting ecosystems, which we can model mathematically and computationally, allowing us to, if you like, conduct computer experiments to really begin to understand how our interventions might impact future developments. So with more and more data, there are some really interesting stories to tell, and there are also some very challenging statistical data science issues which we have to deal with. The digital earth, as I've said, is a concept which is described by the European Union as an interactive digital replica of the entire planet. And the reason that such a thing is be useful is that it can help with shared understanding of the many and complex relationships that exist between both the physical and natural environment and human beings. So if you imagine the digital earth as some form of model, or perhaps some federation of different models, then the data that we can deliver will be really important in terms of understanding and improving our modeling process. As you'll see later on, I have a slide that of course says all models are wrong, but some are just more useful than others. So we need to also keep that in mind when we imagine this vision of this model of the planet. Artificial intelligence is something which a lot of people are talking about in very many different contexts. And I have here a quote from a publication from the World Economic Forum, 8 ways which artificial intelligence can help save the planet. And number 7 is this transparent digital earth. So really this is talking about real-time data, open access data, so that we can begin to model, monitor, manage environmental systems at a scale and speed which previously weren't possible. And the challenges that we can address can include things like deforestation, water resources, air pollution, natural disasters, and of course things like smart agriculture, which is really an area which is growing in interest in many different countries. And again, this is just simply a graphic from a PwC report identifying some priority action areas where artificial intelligence can help. There are 8 of them here, and you can see climate change, biodiversity, oceans, air, weather and disaster resilience. So there's a huge opportunity here for people with skills to use data to help inform and help find solutions to some of these particular challenges which we have. Now, statisticians, I think, are driven by curiosity. We want to learn from data and to understand environmental patterns which we can observe in the data which we collect. And it's all about creating knowledge and improving understanding. And if we do this in a principled and reasoned way, then this will help us better explain, understand, and predict. And going forward, because we want to be working in a timely manner, we want very computationally efficient modeling tools. We want to be working in real time. We want to have inference, so understanding about uncertainty and how that is important to consider as we make decisions. And we want to be able to communicate what we find so that everyone can feel part of the solution, not just simply causing the problem. And as I've said, this is a quote from 1997. So it's about 40 years ago. And what it said was, in 1977, so 20 years before this quote, data were very precious. You didn't really see large and complex data sets. Most data was collected manually. And the goal here was thinking about how to carefully design experiments so that you had the most information possible from as few observations as possible. Things have moved on. We're now in 2021. And really the whole point is that the nature of data has changed enormously. We're dealing with large and complex data sets all the time. The data is very rarely collected manually. We use satellites, we use sensors, we use drones, we use smartphones. Somehow we've occasionally tended to forget that maybe there's still a role for carefully designing our experiments, but the principle really is that things have moved on enormously. And if you imagine in that 40-year period, how will things be in another 10 years' time? We just, the world in some senses is there for the measuring. And as I've said, technology is moving on all the time. The big changes in some senses, which really are, I think, revolutionizing what we're doing, is the accessibility to satellite data, to drone data, to automatic sensors, to the use of citizen science. And the two images on the right-hand side of my slide, the top one is from the European Space Agency, and it shows a map of nitrogen dioxide concentrations over Europe. The figure on the bottom shows tropospheric CO2 globally. So these are unimaginable rich resources to allow us to examine how our environment is changing. We can link all of that to a framework which is well recognized in terms of the Sustainable Development Goals. We have 17 here, and I'm going to use these to frame a few of the examples that I've been involved in with colleagues. The first example, however, is not one that I have directly been involved in. This is about climate, and this is Sustainable Development Goal 13. So the two images here are taken from publications from the IPCC. And the reason I've put these here is I want to show you how in these days we're linking observational data. In the left-hand panel, you can see there's a blue kind of spiky curve. Those are the observational data. We link that with models. And then we use the linked data and models to project into the future. And you can see that in the billowing shape on the right-hand side of the panel. The width of that billowing shape helps us visualize and think about the uncertainty of what we can see might happen under these different scenarios. And similarly, the figures on the right-hand panel are showing recent and future changes in temperature, heat content in the ocean, summer ice. And again, you can see we have data feeding into using models to allow us to make those predictions. But there is always this element of uncertainty. Biodiversity is another big, if you like, issue. And while we've just had COP26 in Glasgow, we also have a COP process for biodiversity, which is ongoing. And there has been one meeting already this year, and there will be a second one, I think, in March 2022. And again, rather than the IPCC, we have other global international organizations. And the report that I'm referring to here was published in 2019. And it says, biodiversity is declining faster than at any time in human history. And some of the drivers for that decline is land use change and our policies for mitigation and how we actually reverse, or at least stop and then reverse that decline in biodiversity, is to think about how we connect different ecosystems and how connections in terms of physical connections and land use and, for instance, stressors like pollution, how they interact and how that then impacts on our biodiversity. And this is a report which was published only about a month ago. It's called Nature 2030. And I've put this graphic here to reflect the fact that we can see the decline. And what we actually really want to do is to halt that decline and then begin to tip the curve back up again. But really, what we can do as statisticians with data, with models, is begin to think about what interventions can we use and what effect and impact will those interventions have, so that we can advise about better ways of managing our biodiversity. Fresh water, critical to life. We were involved in a project which was called Global Lakes. It was a consortium project, and our goal was to investigate the state of 1,000 lakes globally and their response to climate and other environmental drivers. This used archival satellite-based observations based over 20 years. And anyone who's worked with technology knows that technology changes. So part of our work was thinking about how we could stitch together records from different instruments. But historically, this work had been done by people visiting lakes in boats, taking samples of water and taking them back to the lab. So this was an opportunity to look at a really much bigger picture. We've also been working with our environment agencies and regulators to look at something much more local. So the picture on the left shows an image of a river network, and it shows colours representing the concentrations of nitrates, which are diffuse pollutants. And the plot on the right shows some of the uncertainty. Now, what we can do with our statistical model, using the data that we've had from a limited monitoring network, is we can actually infill our network to, if you like, predict what the concentrations will be in locations that we have not sampled. And that can be really powerful to think about where we want to make interventions. A more recent project is this one, which is, well, it's just called the Digital Environment Project, funded again by NERC. And really our goal here was to understand not quality of water, but quantity, using sensors and satellites. And the pictures on the left just show some of the installations of the sensors in this particular rural catchment in Scotland. Now, these were new sensors which were being developed in collaboration with Census, which is a Scottish government-funded innovation centre, with our environmental regulator and ourselves. And the idea was that we would build new small sensors to allow us to monitor river level and soil moisture to provide near real-time information on water quantity, which could be fed back to, in particular in this case, farmers, because this is a rural catchment, and they will abstract water from the river to water their crops. There were lots of different challenges. Data communication was an issue. Some areas were limited in their connectivity, so we had to install new routers. We had data quality assurance issues because as you build new sensors, there's always questions about how good the measurements are and how you can correct them and adjust them. We had to think about how we would bring together data from our sensors, from routine monitoring, from satellites. And again, as I said, the goal here was to really try and improve our intelligence about how to optimize the use of water in terms of the abstraction process, which the farmers could then use for their crops. So multiple data sources, and this is again a very common problem, well, challenge that we're encountering now. Data coming from different instruments, different locations, having different characteristics and properties, which as a statistician, we have to try and find ways to bring together. These are just a few pictures of some of the data that were being generated. The picture in the plot is some of the air humidity data. You can see, oh no, hold on, I just remembered. Yep, pointer, I remembered I could find a pointer. This is probably the first slide that's important for. Each different color reflects a different sensor. You can see there is one sensor in pink here, which has been measuring okay in the beginning of the period and then has gone up and become saturated. So because these were new sensors, what we realized was the casing that the sensors sat within, we had to redesign because this was a problem reflecting the effectively saturation of the sensor because of the humidity within the box that it sat within. But other sensors work very well. Here we have air temperature by sensor. You can see it's much tighter. All of the sensors are very similar. So again, thinking about how we go about modeling these types of data and using them together. We had satellite data. So the European Space Agency provide the Copernicus land monitoring service. So we had 1 kilometer spatial resolution. We could access data on surface soil moisture. The satellite passes over this region approximately once every 5 days. We also had some additional, much finer spatial resolution, only 10-meter resolution from another satellite, which we had to choose when to actually access those data. And just to give you an idea, these are a couple of the pictures from a particular period in time in September. On the left, we have from the Copernicus satellite. You can see the size of the pixels. I've marked out where the catchment is, where some of our sensors sit. And on the right-hand side, you have a roughly contemporary satellite image from this other satellite. You can't see the pixel resolution, they are 10 meters. But together, these are both trying to tell us about soil moisture in this location at this point in time. Air quality is something which is generally improving in the UK, but is deteriorating in other parts of the world. Drivers of air quality and specifically include traffic and weather. We've been developing high-resolution models to allow us to look at, particularly within my own city, within Glasgow, how, for instance, the introduction of a low emission zone, so if you like, the restriction of vehicles which can pass through the zone might impact on air quality, and how that would also then carry through into the impact on human health. We've begun to do some work on trying to design a monitoring framework for soils, and particularly in terms of carbon in soils, because that's a really, really important area when we think about the whole, if you like, carbon cycle. It also impacts in terms of biodiversity. And again, thinking about how do you design a monitoring network that would be global? How do you bring together data from local areas, regional areas, satellites, which are giving us a global image? Urbanization. Again, urbanization is a major challenge. Nearly 1/4 of our population live in cities of more than 1 million or more. The number of megacities is projected to grow. So we have to think about how can we use information about the sprawling of cities and use that in a way to define how we might improve our planning. So again, we've done some work in trying to develop spatial representations of how cities are developing, how they're connected to each other. And there's certainly a lot of discussion with respect to sustainability and greening our cities, to think about the 20-minute neighbourhood so that we can reduce the reliance on transport. We can think about how we provide services and so on. And we've also done quite a lot of work in developing urban indicators to try and understand how we can bring together different attributes about environmental quality, service provision, and so on, and then link these to other social attributes like we have what's in Scotland called the Scottish Index of Multiple Deprivation. So we can look at how areas which might have higher indices of multiple deprivation might also be being impacted perhaps with lower quality or poorer quality regions that they live in, less accessibility to services and so on. So we can begin to bring together our environment, whether it's natural or built, with also our, if you like, our social and economic aspects to see how the connections can be made between them. I've talked quite a lot about satellites, but equally citizen science is a big growth area, particularly because most of us nowadays are using smartphones. There are apps being developed at all times to reflect on air quality, water quality, identifying bats or identifying bugs and so on. So again, this is another different data stream. It's perhaps a little different in the sense of it is preferential. We do a lot of biodiversity monitoring using citizen science. It tends to be often challenging to deal with, recognizing that people tend to go to places that are pleasant to visit. They perhaps tend to go more often when the weather is good. So we have to think about how to use all of those pieces of information when we use these data in our modelling. We've been working with colleagues at the UK Centre for Ecology and Hydrology. They have developed an app to identify when we might have an algal bloom in a river or a lake, and particularly as it might then impact on, as I said, recreational use of those waters. I've been working with colleagues in Italy who are using smartphones to map the dynamics of city life, but more particularly also to think about modelling and identifying an early warning of things like earthquakes. So coming back to these early warnings of, if you like, potential disasters. Now, as I said, all models are wrong, some are useful. So we do need to bear that in mind. But models used with data and used carefully and fully with the uncertainty being attributed to them can be extremely useful. Now, I mentioned global lakes. I'm just going to give you a little bit of the technical detail so that you can understand what we were trying to do. This is an illustration of a lake called Lake Pepsi. What I'm showing you here is just, if you like, the availability of data for chlorophyll in particular as we move through time. And you can see that there are long periods where we have no observations, there are periods where we have complete observations, and there are periods where we have some areas that we have no observations available on. How do we go about modelling this? So there are approximately 70,000 pixels, so small squares, in these images, and they've been observed for about, let's say, 85 months approximately. So what we've been trying to do is we've been using a statistical approach called functional data analysis to allow us to represent the time series of data in a much simplified way, and which we then go on to proceed to model. So just to kind of explain a little more. So this is our lake. Each lake is made up of pixels. Each pixel has a time series. And this plot here shows you, if you like, a representation of the multiple time series from this particular lake. We can smooth this particular data stream to effectively extract from it a picture that explains how the pattern changes over the 12 months of the year, and also what the long-term trend might be. And then we can use other statistical techniques to think about how we might group those shapes because of how similar they are. And we actually have done this for this particular example, which again is from global lakes. And this one is looking at lake temperature. It looked at 732 lakes using the functional data approach. And what we've done is we've clustered the shapes of the curves for the different lakes. and have identified in our map here effectively 9 different groupings of lakes because they are similar in terms of their seasonal patterns. We didn't use geographical location at all in producing this map. So it shows you the power of beginning to understand how some lakes, which might be quite geographically very different in very different locations, might actually be behaving similarly. And then we can explore why that might be the case. I think I might skip this example, but it's just homing in on a particular lake, showing you in the numbered locations where typically historically data would be collected by someone going in a boat. And we've just superimposed that on top of a satellite image of the same lake with about nearly 8,000 observations. And what we've done is, as I said, we've developed statistical techniques that allow us to combine, fuse these different data streams so that we can produce a single map which has taken into account both the satellite and the in situ data and any other data streams which we might have. So providing improved predictions. Modelling connectivity and biodiversity is something that we've also worked on in another project called Hydroscape, again bringing together these multiple different data sources to look at connectivity. Now this is a hugely rich project. We've looked at lots of different species groups. They're all freshwater, and we've looked at different biodiversity measures, and we've looked at different types of connectivity, whether it's hydrological or landscape or different stressors. And we've used that information to construct a model which allows us to think about where we might see these species, how those species are changing over time, and whether they're spreading further north or moving south or dying out, and so on. So the map down here just simply shows a particular outcome for a particular species. So there are lots and lots of challenges here, but lots and lots of opportunities. And I believe a really important opportunity to make sure that we can bring our best endeavours to deal with large, complex data, which really will help us inform around what some of the major environmental challenges actually are. So that's really, I think, my message, that, as I said, tremendous numbers of opportunities. It's a rapidly changing area. There are lots of challenges, not all of them listed on here, but it's, as I said, it's our best endeavour to make that contribution, to think about how we can understand what's happening on our planet and how we can help improve the situation by understanding how things are changing and why they're changing, and what type of interventions might actually help either reverse declines or even stop it, if that's all that we can manage. And it's absolutely worth doing. This, I think, if I remember correctly, is one of those shots taken from the moon, just to reflect on the fact that, you know, what we're living on is very precious. We only have one of them, and we really need to look after it. So here in Glasgow, we have our initiative, which we've labelled as AI Cubed, which is analytics, inference, innovation, and impact. So analytics, thinking about our models, rising to the challenge of new forms of data. Inference, thinking about how we learn and how we use our models and our uncertainty quantification to understand the patterns we see. Innovation, because we need these new statistical solutions. And impact, because the work that we're doing, we want to use to communicate to whether it's regulators, policymakers, scientists, and citizens alike, on how we can focus on, as I said, not just simply contributing to the problem, but actually contributing to the solution to the problem. So there's a number of references here. As I've said, all of this work is done in collaboration with colleagues in Glasgow and elsewhere. It's done collaborating with statisticians and data scientists and environmental scientists. So that was really all I wanted to say this evening. So thank you very much for listening. I hope it's given you some flavour of the nature of the work that we're doing, and maybe some interest in finding out a little more about what statistics can do in this space. So thank you.
Thank you. Thank you very much, Marian. It is truly incredible and fascinating, no? The amount of, well, the perspectives that you reach with so much information. And well, we have many congratulations and several questions. Let's see how many of them we have time to, or you have time to answer rather. They say, interesting conference. It is important to advance in the goals of zero emissions. How can universities and researchers contribute?
Yes, this is a really important question. I think as individuals and as large organizations, we can contribute by thinking ourselves about what our carbon footprint is and how that can change if we think about different policies and so on. As scientists, and for me, one of the really important things is thinking about how we can measure what our carbon footprint is, how we can measure what different activities contribute in terms of the global carbon budget or the local carbon budget, and how we can think about presenting that information in a way which people can interact with, and they can begin to understand how small changes can make a difference and how much of a difference they can make. I think that's part of the answer. I think, as individuals, we can all choose some elements of what we might change that might contribute to this, whether we, have an electric car or we don't use a car at all, or whether we reduce the amount of flying that we do and we use other forms of transport. I mean, while nobody loves Zoom particularly, it has shown that there are many ways that we can interact without actually having to leave our homes or our offices. However, it's also true that it's really important. One of the things I think we've all missed as academics particularly is some of that more informal conversation that you might have, when you're standing in a queue buying a coffee or something like that. But, there are ways that we can hopefully try and improve that going forward. But I think that the accounting system, understanding the measurement process, understanding, I'm not an economist, but, governments have to report in some senses. So there is a carbon budget. People have talked a long time about carbon trading and thinking about offsetting. So one of my colleagues is involved in a project where there's much discussion about planting trees. So where's the best place to plant trees? Scotland has lots of peatland. We don't want to disturb the peatland because that then might release more carbon dioxide rather than sequester some. So these things are all connected together.
So on the one hand, there's the research, and on the other, there are the personal decisions that we
Yes.
have the power to make. And,
Yes.
and as you say, both are crucial, I would say, no?
Yes,
that we,
I think so.
Excellent. Yes. Another comment, it says, interesting how Earth components are interconnected. How is the water cycle affected with warming?
So that's very interesting. I think that's one thing that is very, very clear. Many things are interconnected, and historically we've probably tended to focus on one area, perhaps made a change there without recognizing what effect it might have in somewhere else. So in terms of the water cycle, in terms of climate and changing temperatures and climate warming, well, clearly we can see an increase in temperature in the rivers. That has the potential to have some effect on the biodiversity living within the rivers. Some species, live within very tight temperature bands, or they're comfortable in that band. And as the temperature moves beyond that, they become less comfortable. So we begin to see decline in biodiversity. I suppose that's one part of the challenge. The other part of the challenge is actually in terms of quantity. So we're seeing situations where there's less water in the rivers. I mean, even in Scotland, which most people would not associate with having issues with drought, even we have experience now of low river flow, which can have impacts on what's living in the river, how the farmers can use the water to water their crops and so on. And we are clearly not in any sense in a situation which many countries find themselves in. And I guess the other thing is flooding. So at the other extreme, where again, climate warming perhaps is bringing more extreme events. We're seeing heavier rainfall over shorter periods of time. If the land that the rain falls onto is saturated, then we have issues with the river flows. So again, here in the United Kingdom, and I think globally, there's a lot of interest in what are called nature-based solutions. Because historically, we've often thought about redirecting rivers and perhaps engineering a kind of concrete barriers and things like this. But now we're beginning to think, well, actually what we want to do is let the land work for us also, rather than trying to build all the time to stop.
Yes, indeed. Very complex, no? There's another very big question. How can less developed countries have access to climate data?
So that's, again, a very good question. So, for instance, the Copernicus land use data, I showed a couple of examples of nitrogen dioxide and also soil moisture. That's free. It's freely available. It's global, and so on. The climate data, so there have been a number of, if you like, model comparison exercises. The data are all available freely. They're very, very large, like petabytes of data. So it's a big challenge to deal with in that sense. So the certainly within the US, I mentioned NOAA, and the other organization that I've used quite a lot is the Carbon Dioxide Information Center. So there's really a lot of data available. It may not be specific necessarily always to a more local interest, but globally and probably regionally, there's a lot of data that's widely available, easily accessible, and it's typically, as I said, being hosted by large international organizations. But I absolutely recommend the Copernicus land use service, because I said the data's free. So it's a wonderful resource, and there are, as I said, others as well.
Fantastic, thank you. Yeah, and they're asking, yes, about satellite data. Is satellite data available?
So the Copernicus is the European Space Agency, and I mean, not all satellite data is publicly available, but the Copernicus land use data is definitely. So the European Space Agency is a very good portal, which is the Copernicus service, where you simply register as a user, and then it takes a little bit. You have to read the user guidelines, of course, but it's freely available, and I'm sure there will be others also. But that certainly tends to be where we're recently looking more.
Perfect. Well, another question about processes. No, they're asking, how are the erosion and soil loss processes affected? I guess, yeah.
So I haven't worked particularly in that area. But soil erosion for us certainly typically occurs when we have, if you strip back vegetation or if you have heavy rainfall and so on. I haven't worked in soil erosion myself, so I don't really have any particular insight. But I think, part of the nature-based solution would be to plant again, so that the roots of whatever it is you've planted, in a sense, begin to bind the soil so that it becomes less inclined to erode and so on.
Very well, and that answers the other question, that is, how can soils be protected, which you just explained. There is a comment and a question by Ligia Perez Cruz. She says, thank you for your conference and this illustrative presentation on important resource issues, such as water availability and the consequences of climate change. It is clear that the acquisition of data and observation is necessary for the construction of models and to predict scenarios and adopt mitigation measures. Is there some action underway to reduce fossil fuels, specifically coal, and your opinion on the transition to clean energy?
Oh gosh, these are tricky. Yeah. Well, I guess COP26 has made some movement in that direction, although I think this was one of the pieces of wording in the Glasgow Agreement which I think caused the most challenges. It didn't go far enough for some people, but at least it did mention the beginning of scaling back of reliance on coal from that point of view. And similarly, different countries are obviously taking different views with respect to, for instance, phasing out petrol and diesel cars, going to electric cars and so on. In terms of heating, energy use, again, lots of us use gas, natural gas, but again, thinking about the electrification of these systems. So, it's a difficult one to answer because different countries are definitely taking different approaches, depending on what resources they have, what appetite the populations have, what alternatives they actually have. In terms of the auditing of all of this, every government signs up to some sort of commitment in this kind of COP process. We probably haven't done as well as we might wish to in terms of reaching the targets that we set, or by that I mean not actually going over what we had said we would commit. Here in the United Kingdom, our Climate Change Committee, our devolved governments and our UK government are making statements about, by 2035 we want this to happen, by 2040 we want this to happen, and by 2050 we want, net zero. These are really big challenges. I don't think anybody truthfully knows how we're going to do all of this, but we are at least setting targets and giving ourselves a challenge of moving towards those. And that again comes back to, if you like, my interest in thinking about what do we measure, what can we measure, and how can we use it to inform how close we are to those targets and what we need to do to actually reach them.
Yes, indeed. Very much so. And what you mentioned about the possibility of generating data for the future as well, no? Of looking after data gathering as one crucial activity that
yes.
Many, if not all of us, should do in a way, no? Mm-hmm.
Yeah, no, it's really, really important.
Mm-hmm. This also answers another question about the challenges and the opportunities after the COP26.
Mm-hmm.
It goes in the same direction as well.
Yeah.
And there's another question by Mau Lopez, who says, he's asking, what is your opinion about what Greta Thunberg said regarding why countries don't listen to her?
The blah, blah, blah. Well, I mean, I think, you know, the call to action is clear. What the actions need to be is perhaps less clear in some senses, because it requires every one of us and our governments to change. And we've shown with the pandemic that we can change very quickly. But the urgency and the immediacy of climate and biodiversity, I think now is beginning to become more strident. So I think we will see more changes occurring over the next few years. You know, politics is the art of consensus. I don't know how many people were in the room, but to get everyone to agree is a major challenge, because everyone is in a different circumstance. So yes, compromise sometimes doesn't give you that really, if you like, cutting edge of action. But the point is, we're all being impacted. So we all have to kind of come together and move together. And I sometimes think it's easy to be critical. It's much more difficult in the positions that other people find themselves to make decisions, to implement what will, for many people, be sometimes rather uncomfortable and unpleasant policies. So I think a little bit of both.
Yes. It is truly an education in global citizenship, right? We
Yes.
need to learn to
Yes.
live with others and for the sake of everybody, no?
Yeah. Yeah.
Excellent. There is another question by Daniel Tovar. He says, what do you think is the role of Mexico after COP26? Would you have an opinion of that?
Oh, well, I don't, again, I need to confess, I don't have a detailed knowledge of what's happening in Mexico. But again, you know, as you said, you know, we have one planet. We don't have multiple planets. I was very taken by the Duke of Cambridge's comment about, rather than trying to put a man on Mars, maybe we should be investing in trying to kind of save the planet that we're living on. I thought that was a very telling comment. So I think everybody has to do what is within their ability to do. And I think that's true of us as individuals as well as countries. So I can't really add anything else about Mexico's role in that respect, other than I think diplomacy, working together, these are all going to be really, really important.
Yes. And in that sense, there's a question by Arlet Lopez Trujillo, who is asking about which public policies would be needed to change consumerist habits within the population.
So that's another really interesting question, because in some senses, policy will change behaviours, but equally it might not change, you know, every behaviour that we would expect to have. So for instance, we've seen significant changes in smoking habits. So in the UK and in Scotland and so on, you know, there have been these introductions which said that smoking in public places is no longer allowed. We can show very immediate demonstrable health impacts. We've also been discussing things like
Recording in progress.
As I said, how some rather scarce resources sometimes get used and then we kind of throw them away in some senses. So again, I think we will see a growing recognition that we don't always need to buy new. Now this isn't specifically about water, clearly, but I think the same principle in part is there, particularly around the reuse and how we can, marshal our resources such that we have them, we use them, but we find a way of not just simply saying everything is waste, it has no value, but actually we begin to think about how that waste stream in itself becomes of value. And so there has been some European work, particularly around the reuse of recycled water for irrigation and so on, that type of thing. So I think that's, again, an area which I anticipate will grow. It's perhaps not terribly relevant to water, although there is still a reuse element, but other aspects like some of the precious metals that, some of the phosphates that we need for fertilizer and so on, all of these things often we think of as waste once we've used them. Actually, we need to valorize that waste stream as well.
Excellent, thank you. Ligia Perez says, thank you very much indeed for your answer. The involvement of academia is important. Then there's another very big and very interesting question about citizen science. How is citizen science organized? How can it be organized in developing countries, and how does it contribute?
Yes, again, a really important question. So citizen science, I think, has a multitude of purposes. One, I think, is it allows our citizens to become engaged and to recognize, the value of the trees that they have, the particular plants they have, or the insects or so on. It can be marshaled in a variety of ways. We have, again, in the UK, and I think in other countries, we have a number of long-running monitoring schemes which are based on individual volunteers actually doing something and reporting the data back to a central facility. I mentioned the apps. I showed you the Blooming Algae app. Again, that was a research project that came from the United Kingdom, UK CEH, but that app you download onto your phone and you record something and you get some information back. So it goes into that kind of central database. Similarly, we have apps which allow you to identify bats and so on. In terms of more generally, if you're on Twitter, people are actually mining things like Twitter feeds to understand a little bit about, what the environment might be like as reported by this individual who happens to send a tweet, that type of thing. So there's a mix of more structured, organized situations where the data that you report comes back to a central facility where it's used and you get something fed back to you, against the more unstructured situation where, for instance, you simply are looking at your mobile phone and think, I'll send a tweet to say the sun is shining today, temperature's 22, etc., etc. Hope that answers the question. And we can use all of these in that sense to think about how those inform the situation.
So it's very important to create the channels for the information to be received.
Yes, I think
the other
so.
part, not just the consciousness, but also the place, the repositories.
Yes, yes.
A double thing. Excellent. I don't know whether perhaps Jaime would like to make a comment, or Dionisio.
Hi, hello. Congratulations, really interesting and extremely important. I think this is one of the major problems facing the societies. And the contribution and looking at the questions is extremely good that we have this interest in your conference. In the academia, we need to take a more stronger role and inform the society, inform our governments, develop the strategies, and I am extremely happy to hear your presentation, and I think this is something we really need to look forward and have our commitment and work together on this. And I am also very happy that this is affecting all our countries. It's not just one of them, and so we all share the responsibility. And I'm very happy having this seminar cycle by Universities for Science. I think the international collaboration is it needs to play a key role in advancing with these problems. So I'm looking forward for having closer contact with you and your group, and the University of Glasgow. That's our priority now. And the National University of Mexico has an office. The director is Ana Elena, so we can use this central office in London for collaboration, contacts, and so thanks very much, Marian.
Thank you.
And this is something it will be really very interesting to follow up. So keep in contact and having you back again next year. Thanks very much.
Perfect. Thank you.
And,
Thank you.
It's it's Penelope. To say because Penelope is the Dean of Global Engagement in the University of Glasgow. So this offers us very interesting opportunities for collaboration. And we also have our executive director of UNAM Foundation, Araceli, who is also in charge of the international partnerships. So that will be a very interesting combination to have the three of you working together.
Yes, we'd be delighted to continue a conversation. That would be very interesting.
Oh.
Okay, so thank you very much again, Marian Scott, for this incredible presentation. Very, very suggestive, and I'm sure you will have inspired many people and will continue to, because the life of the video continues even after we conclude. Thank you very much, Penny, for putting us in touch and making all this possible, as well as Fundación UNAM and el Colegio Nacional. Jaime, from the perspective of UNAM-UK, we are very, very grateful to be able to contribute to this fantastic cycle of Universities for Science.
Oh, thanks very much. And thanks again, and congratulations, Marian. It's
thank you. It was a pleasure.
Extremely important and very interesting your research projects and your studies.
Thank you. Pleasure.
And on behalf of the Consortium of Universities for Science, we would like to invite you. The next seminar is next week, next Tuesday, by Steve Chipman. He's a professor in the University of Louisiana State University, and the conference is about the mathematics of waves, the mathematics of resonance. And we hope to see you again in next week. And on behalf of the UNAM Foundation, thanks again to all of you. And muchísimas gracias a nombre de Fundación UNAM, de nuestra directora ejecutiva Araceli, nuestro presidente Dionisio, y todos los organizadores de este Consorcio de Universidades por la Ciencia, que nos acompañen la siguiente semana y el siguiente martes sobre las matemáticas de las ondas, los efectos de la resonancia. Y nuevamente, muchísimas gracias y un saludo muy afectuoso a todos por acompañarnos. Muchas gracias.
Great, thank you.
Muchas y muy agradecidos. Y ha sido
tiene un precio de 15 pesos.
un tema muy relevante.
Mándame entonces las 3.
Y ha sido, la verdad, pues muchos temas de reflexión. Y yo creo que hay que ver con optimismo lo que está pasando. Justamente todo el instrumental que ahora está disponible a través de pues el material estadístico, de la información, de los satélites, pues nos permite ver con optimismo lo que ahora está sucediendo, y además pues se pueden monitorear muchos de estos elementos en tiempo real, y así podemos saber pues cómo está la temperatura, cómo está la temperatura de los lagos, cómo está todo, ¿no?
Cambio de 500.
Entonces yo creo que pues nos tenemos que sentir muy contentos. Son 3 inyecciones. No.
Sí, pero
sí,
no.
Por favor, perdón, es que tenía aquí una consulta. Entonces, nos sentimos motivados porque este avance tecnológico, pero además la conciencia de la gente, ¿no? Aquí se había mencionado a Greta Thunberg, y yo creo que son jóvenes como ella los que ahora están exigiendo a los gobiernos que tomen medidas y que hagan pues todo lo necesario para poder enfrentar esta realidad. Así que pues nos motiva mucho lo que está sucediendo. Vemos con gusto que se aprecia como fondo de pantalla lo que nosotros llamamos aurora boreal, Northern Lights, y es pues muy motivador que haya esta vinculación con la naturaleza que se aprecia desde el fondo de pantalla. Gracias de nuevo a Marion, gracias a Ana Elena, gracias a Penélope por este acompañamiento, y pues muchísimas gracias a todos. Ha sido una gran presentación, nos motiva mucho esta cooperación entre universidades y esta defensa que hoy hay del medio ambiente, pues con mucho más instrumental. Como aquí se dice, pues no había posibilidad hace 40 o 50 años y hoy se puede monitorear en tiempo real. Gracias de nuevo, muy contentos y muy agradecidos. Gracias Jaime, gracias Ana Elena, gracias Penélope y gracias Mario por tu gran presentación.
Ok, y para el otro.
La relación entre los insectos y el ser humano ha sido, a un tiempo, de convivencia y de lucha. Pueden alimentarnos o destruir nuestras cosechas. Al parecer, esta batalla la van ganando los insectos, ya que han provocado las mayores epidemias en la historia de la humanidad. Le corresponderá a la ciencia encontrar en los próximos tiempos la cura para controlar y detener las terribles epidemias y enfermedades transmitidas por insectos. La relación entre los insectos y el ser humano ha sido, a un tiempo, de convivencia y de lucha. Pueden alimentarnos o destruir nuestras cosechas. Al parecer, esta batalla la van ganando los insectos, ya que han provocado las mayores epidemias en la historia de la humanidad. Le corresponderá a la ciencia encontrar en los próximos tiempos la cura para controlar y detener las terribles epidemias y enfermedades transmitidas por insectos.